students. Today we will learn about the binary logistic regression. Any idea about the binary? What is the meaning of binary?
It's something which is two, sir. Which is
Correct, Vishal. Binary means two. So when our dependent variable will be categorized into two categories. Okay, and these two categories will be the factor. For example, pass, fail. Okay. And we have some metric as well as the non-metric data. And based upon that, our intention is to classify or is to predict, that is, who are the students their chance for passing is high, and who are the students their chance for failure is high. So we have to find out what are our variables. For example, nowadays you find school provides the mark sheet about the pass and fail. And in the mark sheet, you will find out not only the marks of different subjects, but also some behavioral characteristics. Okay. So we have to find out, that is, which subject or which type of behavior can predict the classification of the students into two groups, that is the pass and the fail. So that is the dichotomous. Now this dichotomy may be genuine dichotomy or the arbitrary dichotomy. Arbitrary means you have the data and you have the cut point. For example, 60% is your cut point. So 60% above means successful students and 60% below means unsuccessful. Okay. And the genuine dichotomy. Genuine dichotomy means male, female, boys, girl, etc. So that is the genuine dichotomy. So this dichotomy classification is clear to all of you? What is the difference between the genuine dichotomy and arbitrary dichotomy?
Yes, sir.
Yes, sir.
Okay. So now our tendency will be what is the probability. So one probability may be the 0. Another probability will be the 50% chance. Another probability will be the 1. So 0 and 1. Two major probabilities. One is the 0, another one is the 1. And within this probability, from 0 to 1, there will be several probabilities, that is less than 50% and above the 50%. So 50 to 1 and 0 to 50. So if you draw one S type of curve, then the head of S is 1. The middle part is the 50% and the tail part is the 0. Okay. So this is the curve. So it is called the S curve. S curve indicates how much probability is there for classification. Therefore, when we apply binary logistic regression, we find confusion matrix or the classification matrix. In the confusion matrix or classification matrix, we will get the observed data distribution and the predicted data distribution. So prediction is based upon the statistical modeling. Observed is the actual. For example, in the industrial setup, you have the performance appraisal data. That is your covariate, or they are the predictors. And your dependent variable that is the absenteeism, high absenteeism and the low absenteeism. So you want to find out that is which type of trait or which type of behavior can make maximum classification between the two groups. This is clear now?
Yes, sir.
Okay. So based upon that, you can take some decision in your organization. For example, you have noted that is the communication skill, team cohesiveness, and the mental health. Maybe these three are your strong predictors for the classification of high absenteeism and the low absenteeism. Now the industry can take proper decision based upon the B coefficient. So you will get the B coefficient. Now, I am asking you whether you have any SPSS in your laptop.
Yes, sir.
Okay. Do you have any data for the classification? Any data?
Yes, sir. I have a mental health data, sir.
Okay.
Yes.
So can you share?
Yes, sir. Please give me a minute. I'll just open it.
Okay. Shara, do you have any data?
Sir, I don't have my laptop with me right now. It's still in college, but I do have data on my phone if I can access SPSS online by any chance.
No, in phone SPSS is not possible. Okay, Bishali is demonstrating, so you can understand and later on you can check.
Yes, sir. I'll write down the procedure and practice over the weekend once I have my laptop with me. Really,
Okay.
really sorry for this.
Um, Sir, I'm sharing the SPSS screen. Is it
Oh, very
visible?
good. So, can you tell me your data is the male and female? Okay.
Yes.
And you have the other data, that is the academic. What is this? You cannot read.
Academic pressure, sir.
Academic pressure. Another one is the academic.
Academic pressure, Z scores. Then there is work pressure,
Okay.
then CGPA,
Okay.
then study satisfaction and job satisfaction.
Okay. So these are your independent variable or dependent variable.
Um, so, like these are independent variables.
Okay. So what is your dependent variable?
Dependent variables are the depression score is there, 1 0. One is depression is present, and 0 is depression is absent.
Okay. So now it is very clear, that is your dependent variable is dichotomous, and it is the arbitrary dichotomy maybe. So you have administered some questionnaire for measuring depression, right?
Right, sir. Sir,
Okay.
actually, this is a sample data I've taken from somewhere.
Okay, we can check.
Yes.
And so now we can think, that is whether the work pressure, academic pressure, so which type of pressures or which type of stressors can make more between group classification. So between group means depression and the no depression. Or we can say that is the depression present and depression is least level. Instead of the no depression, we can write down no less depression or least depression, because the depression is common. So now you click the analyze,
Yes, sir. Analyze,
and there is regression.
regression,
Uh, and then you click the bivariate, binary logistic.
binary logistic,
Uh, then your dependent variable will be the 1 0, that is the depression.
yes,
You select it. And your independent variable is the CGPA, that is, and the academic pressure and other what variables you have told.
the academic pressure is there, work pressure not significant, CG
Okay,
study.
academic pressure.
So should I add it in selection variable?
Huh. Everything will be in the covariates.
Covariance.
So they will be the covariates.
So we have
Academic
academic.
pressure, work pressure, whatever the stressors are there, you write down as the covariate.
Yes.
Okay.
Yes.
Now you click OK.
Okay.
Now you show your output.
Yes. Yes. I think this is not good. Yes, sir, I'm showing the output window.
Yeah, this is the case processing summary. And this is your dependent variable. That is also 0, 1 type is there. Then you go to the no, you go below. Model summary, after that classification table. Yeah, classification table. So you find that is the 72, no? What is written?
Yes,
72.3,
72.8, sir. Yes.
72.8%. So 72.8% correct classification is there. Okay. That means 28% are misclassified.
Hmm.
Now you can find out variables in the equation.
Hmm.
There, what is the first variable? Academic pressure.
Yes, sir.
And what is the B coefficient?
0.809.
0.809. So this is very high. And that is also significant, no?
Yes, sir. 0.0011.
Okay. So, and what is the next one?
Work pressure. The B coefficient is 0.041.
0.04. Okay. And what is the next one?
Study satisfaction. The B coefficient is minus 0.229.
Okay, 0.23. That is significant.
So yes, less than 0.001. Uh, Sir, would it be okay to say that it has a negative relation with depression?
Uh,
Hmm.
it is related to that with the depression. What is the next one?
Job satisfaction. B
Uh,
coefficient is 0.253.
is it
Significant.
significant?
Sir, it is 0.600. So
No,
that's
not
quite
not
more
significant.
significant. Yes.
Not significant. That means academic pressure is the strongest predictor for the
Hmm.
discrimination between the two groups. Okay, that
Yes.
means that depression occurs mainly due to the academic pressure. So you have collected the data from the student population.
Yes, sir.
Okay, so it indicates the your model is valid. 72% correct classification is there.
Mhm. Sir, I'm just having a little confusion in understanding what do we mean when we say that 72.8% classification is correct? That does that mean
That means you're observed and the predicted.
hmm,
You check your predicted and your observed.
okay,
And there you can find out the percentage and how many people in your observed and the predicted. If you find that is the observed and predicted very high, so there is a high probability for the correct classification.
so sir, here in this case, can we say that 28 or 27% of the cases are not
They are
marked right.
misclassified. They are not classified properly.
So
So
their depression score
misclassification
would,
is there.
sorry,
So
sir, please.
misclassification is there.
So their depression score, predicted depression score and observed depression score would be different if we calculate that.
Yeah.
Okay, sir, I understand. Thank you.
So this model is called the supervised machine learning. Why it is supervised machine learning? Because initially you have classified the data into two categories. Here data means your criterion variable. So you have the criterion variable and you have already done the classification of the criterion variable. Okay. Therefore, this is called the supervised learning. So there are three types of machine learning, as I have discussed earlier. One is supervised machine learning. Another one is unsupervised machine learning. Another one is the reinforcement machine learning. So here you will learn the supervised and the unsupervised machine learning. So today you have learned the supervised machine learning. So why supervised? Because you have the criterion variable. Okay. For that reason, you have the criterion variable and that is predetermined. Again, your classification is there. That means your dependent variable that is also classified based upon certain assumption. Therefore, it is already classified. And your tendency is to find out which predicting variable is relatively more important for predicting the change in your dependent variable. So your dependent variable is the depression and the least depression. Okay. It is determined by the big depression scale or some other scale. Have you used the big depression?
Yes, sir,
Vishnu?
BDI, yes, sir. Big depression score.
So based upon the big depression, you can classify them into two categories. Very high group, another one is the very low.
Yes.
Instead of the no depression.
Yes,
Because
sir.
depression is a common phenomenon. So this is clear to all of you.
Yes, sir, this is clear.
This is the binary logistic. Okay. And you can test your result in another way. You can go to analyze.
Okay, sir. I will just change the screen. So, analyze.
Then you go to the general linear model. Uh, then you click the multivariate. Uh, then you write down your dependent variable. What will be your dependent variable?
Depression, sir.
Depression. And what will be your so this depression is not your uh, classified, no? It is a metric data.
Sir, it is classified as 0 and 1.
Oh,
Then,
then it will be the fixed factor. So this will be the fixed factor.
okay.
Depression will be fixed factor. And your other variables,
Yes, sir.
that is academic pressure and other variables, that will be the dependent variable.
That will be the dependent. Okay.
Dependent variable, not the covariate.
Yes, dependent
Uh,
variable.
and what other variables? Work pressure. Uh,
Sleep duration we can also take.
okay,
For citizens' strength. Then we can take study satisfaction.
okay. Then you click the OK.
Yes.
Now go to your result section,
Yes.
output. Now here you can find out what is the Will's lambda.
Sir, it is 0.082.
That means highly significant. So the discrimination is very good. Okay. Now you go to the effect. That is the test of between subject effect. You go to the subject, and there you will find out the academic pressure. It has more effect, no?
Sir, academic pressure.
It has more effect.
Yes, sir. It is 0.000.
Uh,
Yes. Whereas work pressure is 0.576.
yeah,
So,
that means whatever the results you have received through the binary logistic, that is also validated in this model. Okay, so multi-model you have applied. One side is the binary logistic, another one is the MANOVA.
yes, sir.
Now it is clear?
Yes, sir. It is clear.
Yes,
Okay.
sir.
Shara, any question?
So, not question as such. I was a little confused in multivariate analysis. How did all those variables become dependent variables? Like dependent variable in
Yeah,
shall
dependent variable will be, what is the dependent variable? That is the academic pressure and other things. And independent variable is the depression. Therefore, it becomes the fixed factor. Okay. In case of the ANOVA or MANOVA, your independent variable will be categorical in nature. Okay. And your dependent variable will be metric. So It is just opposite of the binary logistic approach.
Understood, sir.
Okay. Okay, thank you. Acha, whether you have finished the assignment, if not, please you do it. And if you have any question, you can ask me.
Okay, sir. It's
Thank you,
done,
sir.
sir.
Because time is there, so you can do it.
Yes, sir.
Have you read the question? 3 questions are there, very simple questions are.
Yes,
If
sir.
you have any confusion, then you can ask. Otherwise, I will close it.
Sir, I don't have any questions.
Okay. Shada, is it okay for you?
No questions, sir.
Okay, thank you. So now I'm closing the session.
Okay. Thank you, sir.
Thank you.
Thank you, sir.
Yes, good night. Best wishes.